Okay, the next thing we're going to look at is reflecting your function across the x or the y-axis. So first we're going to graph f of x equals 2x minus 6. So that is just slope-intercept form, 2x minus 6. We're going to go to a negative 6 on the y-axis, plot that point, and then your slope is 2. So you're going to go up 2 to the right 1, up 2 to the right 1, and you're going to plot all of these points. I'll make that a little bigger so it's easier to see. And this is our function this time. Our last example dealt with a parabola, and now we're dealing with this line right there. So that's f of x before any transformations. All right, so now what they want us to do is graph the function g, a reflection of f across the x-axis. How are their equations related? So all that we're going to do is we're going to take each point that we plotted and we're going to reflect it across the x-axis, and that will be our new function. So this one down here at negative 6, reflecting across the x-axis, we'll put it above the x-axis at a positive 6. So that point is going to go there. I'm just going to take each point, and you can almost just count from this point 1, 2, 3, 4 to the x-axis, and then go 1, 2, 3, 4 above it, and plot that point. You're just reflecting every point across. This one on the x-axis will stay, and you're going to get this straight line. So this is g of x. Okay, now they want us to compare the equations. Well, that is a linear function, so we could come up with the equation of g of x just by looking at it. G of x equals our slope, if you follow from point to point, let's see, down 2 over 1, down 2 over 1, down 2 over 1. So our slope is negative 2x, and our y-intercept, we started up here at a 6 on the y-axis, so plus 6. All right, so we came up with that equation because it's a graph we can just look at and tell. But if you are reflecting across the x-axis, let me switch colors here for you. Our new function will be a negative f of x. So if f of x is 2x minus 6, I'm going to plug in that 2x minus 6 with that negative out front. That negative would get distributed to give us a negative 2x, and then negative times negative 6 is positive 6. You can see that that's the equation that we got from looking at the graph. This is g of x. So right here, that's what the equation looks like when you reflect across the x-axis. It involves a negative, and the negative goes in front of the entire f of x function. Okay, so part B, same line. I'm going to pause and draw that in. So there's the same equation. That's our f of x function. I'll label it right there. And now they want us to reflect it across the y-axis versus the x-axis. So when you reflect across the y-axis, every point is going to reflect left and right. So this point at 6 won't change because it's on the y-axis, but this point right here, I'm 1 away from the y-axis. So I'm going to plot the same point 1 in the other direction. So that point will go there. The next point, I'm just reflecting right there. Then we'll go there. So I'm just reflecting every point across the y-axis. I'm going to draw that in. That gives us, this is our g of x. Okay, how are the equations related? Well, again, we could figure out this equation right here. The slope is, if you go from one point to the next, down 2 to the right 1, down to the right 1, down 2 to the right 1. So g of x is equal to negative 2x, and then our y-intercept was down at a negative 6. So how does that relate to f of x, which is positive 2x minus 6? You can see that just the 2 turned negative, and that was it. The y-intercept stayed the same. Here's how reflecting across the y-axis work. If you're going to reflect across the y-axis, your new function g of x will be equal to f of, now the negative is going to go inside with the x. What that looks like, our f of x function is 2 times, now our x is going to be negative minus 6. So all I did was I took this 2x minus 6, and it says the x will be negative, so I made the x negative. And then we just keep simplifying. 2 times negative x is negative 2x, and then that minus 6 carries down. And there's our g of x function, which we found up here from looking at the graph. So right here, that's how you do a reflection across the y-axis. You don't put the negative out front like you did for the x reflection. You put the negative inside the parentheses with the x.